Hello, pharmaceutical R&D scientists. My name is Laurent Pan. I'm the founder and CEO of Innocence. I'm here to introduce you guys our SentinusAI sequence-based protein design AI platform, and wish this would boost your R&D strengths in your therapeutic discovery for protein drugs. There are three parts of my presentation. First, I'm going to introduce the technology platform, and then I'll show some case studies, and then introduce our business model and service model. So the platform is invented in order to overcome some of the limitation of the current antibody screening platform, such as the phage display and hypodoma. They normally take months and with very high cost and low success rate, and always often involving animal sacrifice. And comparatively, Innocence SentinusAI platform will only take about 1 month with very low cost and higher success rate, and in the whole process does not involve the animal immunization. The entire engine has several AI modules that are able to compute different part of the therapeutic properties for any drug candidates, from affinity to its immunogenicity and humanization to its development ability. So I will introduce those properties one by one. First of all, let me introduce a general workflow of how the AI engine works. We take the target sequence, and keep in mind we don't necessarily need the 3D structure of the target protein to start with. We only require the sequence. And through our AI engine, it will perform a de novo in silico drug molecule design process with a very high throughput virtual screening process to enumerate 10 over 10 of possible candidate antibodies or other type of protein modalities. And then it will, based on the objectives of the optimization, and start from affinity or other activity that we can optimize those property one at a time, or multiple property at a time. And then we shortlist the top 10 to 100 candidate molecule for wild lab production and test. And this process normally take about 2 weeks in nowadays high throughput lab technology. So the entire cycle from compute to design and build and test is about maximum a month to be accomplished. And normally after 2 or 3 rounds of this computational and wet lab iteration, we'll be able to find the best candidate with desirable properties. The technology behind this platform is very similar to ChatGPT. It may be counterintuitive because ChatGPT is a AI system that process human language. However, our technology is also based on very similar algorithm. It's called large language model, but however, it performs on the sequence of amino acids instead of sequence of human language. But it's worked equally well, so that we take the 1D language input and trained and take those hundreds of millions of sequence information and trained by advanced language modeling algorithm, and also fine-tuned with experiment activity data, and in the end, we'll be able to accurately generate the desirable proteins we would like. So it's the truly cutting-edge next generation protein design system. We benchmark this type of platform across the industry. And then in the previous generation of technology, people would require a physics computation between two protein 3D structures. However, we only take the sequence and using a language model AI black box to do the prediction. However, the accuracy of the free energy change prediction is about 10 to 15% increase compared to the conventional 3D physics-based model. Another matrix is the computational efficiency. The previous generation of software, the computational efficiency for protein-protein interaction is very limited. Normally only take a few days. That normally takes like a few days for hundreds of computation and takes like tens of thousands of days for up to 10 over 6 magnitude of possibilities. However, in our advanced system, even up to 10 over 10 of magnitude of possible interactions, we'll be able to screening finish in 5 days. So in this case, it is a really a breakthrough in terms of both computational cost and also the magnitude of the possible sequence you can virtually screen. And this would bring us new possibility of be able to calculate not just one target and candidate interaction. We'll be able to also do the off-target screening or multi-target screening as well. Here's some case study I'd like to introduce. Case study 1 is the in silico discovery of antibodies to neutralize SARS-CoV-2, and it's also a broadly neutralizing antibody. And in order to do that, we first takes the group of COVID-2 strain sequence, and then we find out there's 64 unique strains on the binding epitope, the binding domains of the SARS-CoV-2, and then we take them and we virtually design a 10 over 8 of magnitude possible antibodies against each of those strains of S protein binding domains, and then we'll be able to calculate all those possibilities in a week, and we shortlist the top 50 sequences from the libraries for expression and production and a binding assay. So the binding assay, we use the ELISA compare with the positive control of different COVID strains to the approved treatment. As you can see that we have at least 40% hit rate for our AI design antibody against at least wild type and delta our RBD protein of the SARS-CoV-2. And we'll also have 7 antibodies are actually are mutation resistant that effectively against Omicron that comparatively the approved treatment already lost the effect. And the second round, we also did the wet lab in the real viral assays to test, and we identified 10 antibodies shows neutralization effect. At the same time, we try to see if the model be able to calculate antibody that is based on the current affinity, being able to do affinity maturation for a particular strain. So we take the starting point of the Omicron antibody we discovered in the previous experiments, and then we did another computation and take 20 candidates, and 8 over 20 candidates has pretty good binding, and the hit rate is also increased the second round of the computation. And then the affinity increase is about dozens or even hundreds of times compared to the first round of calculation. So in this case, we see this model is able to do multi-target optimization and also be able to generate neutralize antibody and also perform affinity maturation based on unknown templates. So in that case, we further challenge the model by more diverse type of antigens, such as some human receptors or proteins, and also mouse antibodies as well. And then we find out that we when we perform a 5-target multi-target affinity maturation, against 5 different proteins that we discovered that the top 34 we selected for expression purification. They have 10 out of the 34 mutate antibodies that reached an oversaturated states of binding, as the lighter color shows. And among the 10, there's cross-binding antibodies. There's 10 to 10,000-fold of affinity increase, which is very surprised at the time, but this is also shows how capable this model is. And the third case study is we try to perform affinity maturation to one of the customers' protein that has to be marked here that under confidentiality, but basically we designed 15 antibodies over 2 rounds and be able to find 7 and 17 antibodies, totally 48 hit rate with a 10 to 100-fold increase. And all those studies been finished in less than 2 months with very minimum cost. And this the fourth case study is a de novo antibody design. So this case is the client brought a very new target with no starting points, that no known antibody binds to this target. So we have to do a de novo design from scratch. And the first round will be able to identify 7 diverse antibody sequences and express successfully. And then out of them, there's a weak binder. And then we further amplify this templates by compute another round. And the top 20 was tested with significantly higher affinity. And then we'll be able to find the second round of the experiment where are able to find the desirable antibody. So we also performed retrospective validation on different type of protein family, such as CD269 and LAX3 and CD20, CD137 and CTLA4, as such that we take the actual experiment data with the AI ranking score and found a pretty good correlation between different protein families. So this is like so far the case study, and then the entire research workflow is we will take the test, and then after the down payment, we'll perform a target analysis for your project and perform the computational work, and then we selected the top antibodies for production and testing, either in-house in your lab or in our vendor lab, and then we perform the report, and then the project is complete. So the entire process takes roughly a month. So this is our contact information that we welcome your inquiries about your scientific problem, and we're very happy to solve it with our SentinusAI platform. Thank you very much.